Hello, and welcome to this video. In this video we're going to do a short introduction to the AS topic of mechanics and hopefully get a grip of what we're going to go through and why this is all actually relevant and why we need to know this. So mechanics is basically just the study of motion, how things move, why things move, and it's allowing us to then predict how things will move even if we have no actual physical way of doing that motion. But for mechanics, when we think about how things move, we should already be familiar with a few ways that we could actually quantize how that motion acts, or a few approaches in order to predict that motion. So the first one would be looking at forces. Okay, so we could ask what forces are acting on this object. How are those forces going to change the way that this object moves? So that's our first thing that we're going to look at in mechanics. We can also look at just its regular motion, so things like its speed, or in our case now we're going to be using velocity rather than speed. So things like velocity, acceleration, those kind of variables. So these are just I'm just going to refer to as motion variables. So it's if something is now moving, what is its velocity, what kind of displacement does it have, how long has it been moving for, what was its final, what was its initial velocities, how is that relating to the acceleration, and those kind of things. But we can also say if something is moving, then we could characterize its motion in terms of its momentum. And so we know that if things are moving, they'll have momentum, and that momentum has to be conserved. And then the last thing we can do, thinking about how we can conserve momentum, we also have to conserve energy. Okay, so these are the main four things that we're going to break down this whole mechanics things into. But there are some preliminary steps that we have to take before we can dive into all of these sections individually, and that's to define a few key things. So for mechanics, or the mechanics or motion modules that you'd have done at GCSE, you'd probably be working in a lot of scalar quantities. So it wouldn't matter too much in most of these examples whether your quantity was a vector or a scalar, because you'd just be working with the magnitude. So what do I mean by scalar or vector? So a scalar is just a number, right? So I could say that the distance that they've traveled is 5 meters. Okay, so that's a scalar quantity. So it's just the magnitude of that measurement. So if I was to time something, for example, this would be a scalar quantity. So let's make a list of examples of scalar quantities. So time would be one of them, because we would have just it takes 3 seconds or it takes 15 minutes or something like that. To show the difference, let's also write down what a vector is. So a vector is the same thing. It would be a magnitude, but in this case it's when things move in a specific direction. Okay, so magnitude in a given direction. Okay, so this is the difference between the two. Okay, so time doesn't have a direction. Technically, you could use thermodynamics to say, sure, time is always moving forward but not backwards, but in terms of spatial coordinates, we would only ever have, this is an amount of time, we wouldn't ever have its time is in the x plane or the y plane or anything like that. We would also call speed a scalar quantity. Okay, because the speed is just how quickly something's moving. If you measure something's speed, you could say it's traveling at 50 meters per second or 5 meters per second. You're not saying which direction that thing is moving in. Okay, so the difference is the scalar of it would be speed, whereas the vector version of speed we call velocity. Okay, because we have that speed is moving in the x direction or in the y direction. And so we have to change our variables. We could also have distance. So like my original example, the distance is 5 meters. That would be a scalar quantity. But if we wanted to make it a vector, we would have to call it displacement, since displacement actually takes into account where you've started from, where you're going to end up, and the direction that you've actually had to move in order to get to that new place. Okay, these are a few examples. We will have to look at all of these individually when we get round to them in each individual video, and be able to explicitly state whether each of these things is a scalar or a vector. Okay, but what you'll find in general is mostly we're going to have to use vectors, okay, because now we're going to have motion where things will change direction. So for example, one of the things you might encounter at A level is where you throw a ball up in the air. We know it's obviously going to get to some maximum height and then it's going to fall back down. Okay, so because we have that, it starts going up and then it comes down. We have to make sure we're actually defining what direction it travels in, because if we don't, it could leave the impression that this ball is just going to get thrown up and then continue traveling up for that whole distance. We have to specify what direction this thing is moving in order for all of these equations and things we're going to make sense. Okay, so speaking of equations, the two main equations that you would have met already would be that speed is equal to distance over time. This one you would have met all the way back key stage 3 maybe even before that, and this stays the same. The only thing we're going to change is the variables here. So this whole thing is a scalar equation, okay, because speed is scalar, distance is scalar, time is scalar, so we get 3 scalars, so we're just working with everything in terms of scalars. Like we said, for the most part in A level we don't want to work with scalars, so this whole equation, we know speed is going to become velocity, so we say velocity is equal to, and this distance is now displacement, but this displacement we're actually going to have a symbol S for. So this is where things will get a little bit tricky for most people, because we're changing what the variable is like the symbol for the variable. This can happen a lot in physics. In physics, we literally just choose a letter, give that to that variable. So you should be able to be comfortable in saying which variables correspond to what. But displacement will always be S. But we're not just going to look at the displacement, we have to look at the change in displacement. Okay, so in your formula sheet, you'll see this kind of symbol, and it's still divided by time. So this is the equation for the velocity. So it's the change in displacement divided by the change in time. This symbol, delta here, just means change in. Okay, so it's we're saying, let's imagine we have some sort of coordinate system. So let's just have an XY plane. So this is X and this is Y, and we start this point here we can call S1, and we know that after some time through some path, so maybe the path is straight there, maybe the path goes around like this and then gets to there. This is the thing that's much easier with vectors. It doesn't matter what path you take, your total displacement is still the same because you end up in the same place. And so the change in displacement is just going to be S2 minus S1. So it's your final displacement minus your initial displacement. Okay, and the time is then going to be your final time minus your initial time, or the amount of time that that thing has been traveling for. And then another one that we would have seen is the acceleration is the speed over time. So we might have referred to it as acceleration is, I'm going to write out full speed rather than just putting S. It's the speed over time, or more specifically the change in speed over time. Again, we're just going to change things up a little bit and make them into vectors. So we're going to say it's the change in velocity divided by the change in time. Okay, and these are your two core bases of what these what everything will be built on from here. Okay, so what we need to now look at is how would forces cause motion, and how do they change when motion changes. How would we relate all of these velocities, accelerations, displacement, time? How would we get things so that we would actually be able to work out any of them as long as we know a few of the other ones? How would we look at momentum? How do we make sure momentum is conserved? And how do we look at energy, and how is energy conserved? So this is what we're going to look at throughout this topic. Thank you for watching.